No. Is it C-E or S-E?
S-E.
Yes.
C.
See, I don't spell very well. I went to Bingham High School. Then I went to Brigham. Your dad's a teacher? Oh yes, we talked about this. Now he is a what?
Well, he was. He wasn't really like completely convinced to go
They might have better things now, but they were the English. You should hear my whole family that went to English wrestling. Who doesn't like to have a supplement in that, you know?
Are you in the FFA?
I was not in the FFA. That's okay if you would like to get it. It is a great program.
It's so boring.
What? That's kind of rude.
No, the class.
What's the
Hey,
word
we have
after
a girl that
does
joined
that say
FFA.
piecewise
We have
function?
many people. Tanner's in FFA.
I know, I'm in FFA.
That's a
Kylie's
piecewise function.
Well, then you're not using it. Here we go. Piecewise functions. Here is an example of a piecewise function. Now, don't let it scare you because it's not hard. Just bear with me.
Is that a snake?
It's like one of those braces.
Bracket?
Brackety brace, yeah.
Yeah.
Okay, how many pieces does this piecewise have?
4. 7.
I hear 4, I hear 2, I hear Lance, he's probably true.
Was that right?
No.
Sing 4?
2. Huh? Now there's 4, you might think there's 4, but there's technically 2, yes. There is. I haven't even taught you anything. How can we have that? I don't know what you're right.
He hasn't taught us in the... You shut up, you don't know.
Quiet something.
I do not see you.
Just a squiggly thing, man. Just a squiggly thing.
I think you're...
Okay, there is 2 pieces. Now, I have a first question. My first question, if you know this, don't kind of shout out, meaning like you've seen this before. How many of you guys have ever seen piecewise before? You have? Because it's been showing you what's your bucket spot. If I asked you, what is f of 2?
2.
Okay, X's are. That's awesome. But what piece do I plug it into? No. The top one. Okay.
Because
You
big
say the
zero.
top one, Ilaria. Go for the top one. Why? You got to give it to me, not just cuz. Tell me why it's the top one.
It's big.
It's
large one.
Okay, so you guessed. You were right.
So it's negative.
Do you know legit? You think? You said the top one, so I want you to. 2 is less than 0? That's not the top one, huh? It's the bottom one, because 2 is greater than or equal to 0. I'm going to use this piece. 2 works for this piece of the function, because I'm only using the x values that are 0 or greater down here. So that is 4 times 2 plus 3. So therefore it is 11. Because notice see how 2 is greater than 0? So then I'm putting in that piece. Equal to, so where would 0 go? If I asked you what's f of 0? It would go in the top or the bottom? Bottom. Okay, I heard top over here. Who said top? I want to know. It would be bottom. Tanner, explain bottom. Is 0 less than 0? Is 0 greater than 0? Is it equal to 0? So that's why this one would work. Because 0 is less, greater than, or equal to 0, correct? So therefore, we'll plug it in. 4 times 0 is 0. 0 plus 3 is... I do 3. Does everybody understand the values I'm finding? It's a very simple concept. What you do is you look for this position a point will go into and plug it in. But my goal today isn't just to find random facts of f of 2, f of 5, or whatever, or f of -1. Where would f of -1 go?
Right there.
Why the top one? Negative 1 is less than 0. So Ilaria, does that make sense? You said you were kind of confused a little bit. Are you okay now? Okay, so let's, once again, if I ask for f of negative 1, is negative 1 less than 0 or is negative 1 greater than or equal to 0? So that's the top portion. Does that make sense? So therefore I plug it into the top function. Okay? Alright, here we go. Here's what we're going to do. So I'm going to graph this. And it needs a piecewise as at least 2 function. You could have 8, you could have 3. The most you're going to do today is 3. But it's not really bad. It's not, guys, this is a very simple lesson. It's not hard. Like I said, it's a tedious lesson, meaning there's a lot of itty-bitty steps to get to where you need to be. That was not hard. It just took some steps to get there, right? Okay. Here we go. So, we're going to start right here with Tanner because he's on his phone and that kind of hurts him a little bit. So, Tanner, if you put it away just for 30 seconds, then you can be done with just 1 second. Tanner, give me any x value you want to pick, but I would hope that you're going to pick one for this one. Tell me about it. Don't listen to Nick because he's wrong. 3, does that work in the top value? Is 3 less than 0? Negative 3. That's a great point. I'm going to stick with negative 3. Thank you, Tanner. So that works. Oh, I'm going to kill someone.
You get mean to me.
It's okay. You can handle it. You have nice biceps. So, now, with that being said, negative 3 is less than 0. So it does work up here, right? So I'm going to go, okay, what's negative 3 times negative 3? 9 plus 2 is 11. So I put it right there. Is everybody good with me? All I did is I put the value in, I got a value out, I plotted it on the graph. Well, that's where we're going to, because isn't a graph a collection of points so close together it looks like they touch? That is what a graph is. Let's come over here. Yes, ma'am. That's all values are. Plug in x's to get y's. Working on my belly. Okay, you are next. Pick me another value. Pick me another. Okay.
Okay, so you just put that negative 3 in where that x is to the left.
Pick me another one.
Okay,
Don't go negative 4. I know you were.
negative 6.
Nope, not doing it. Nope, not going to do negative 5 either. Not negative 6, I'm not doing it either. Negative 1, I'm going to go with Christian. What is this? Is negative 1 less than 0? Okay, we plug it in over here. 3 times negative 3 times negative 1 is 3. 3 plus 2 is 5. 1, 2, 3, 4, 5. What should this look like? What does that y equals negative 3x plus 2 look like? It is a line. Right? What's another good value to pick since you actually know how to do this? On the top one. I know how to do this, Mr. Robert.
I kind of do. This one is more tedious.
Well, tedious means it's easy. It's just troublesome.
Yeah, that's what I was doing.
Oh my goodness. So now I'm going to pick a 0. Why? Does 0 work here? But why am I picking 0? Can anybody tell me the reason why? Tanner! It doesn't have to. I understand what you're saying. You're saying because usually when we draw lines, we look for the y-intercept. That's what you're saying. But that's not the reasoning. Okay? Think about this, guys. I'm going to ask you a question. I want you to truly think about it. Listen to my words, please. What number is the largest number smaller than 0? What is the largest number smaller than 0? That's actually a very, very small number, isn't it, Tanner? Sure it is. Would you rather have negative $1 in your bank account or negative $infinity in your bank account? Which one's greater? 1 is not even the largest number.
No, it's like,
Negative point forever, where I can put a 1, but then technically there's not such a number, technically, right? Because I could have an infinite amount of zeros and then put a 1 on it, almost. You get what I'm saying?
Yeah, you don't know.
So there's
when.
really not a place. So I have to use the value here 0. Now, how many of you guys remember when you did inequalities back in the day where you shaded the side? And then you had closed and open circles. You guys remember closed and open circles? So would this be, when I pick 0, a closed or an open circle?
right.
Open.
Open, because we do not want to be that value. We're going up to that value. Okay, does that make sense? Because we can't, 0 is not less than 0. So it doesn't work. But negative 0.0001 does, but it's hard to graph that. Does that make sense? So let's pick 0. Negative 3 times 0, 0 plus 2, 2. So I'm right here. And that should be an open circle. Does that give me a good enough value for a graph? Sure. Looks like that. Well, is that an equal to or not equal to? So therefore it's not equal to, I don't want it in part of my graph. Okay. Hi, you got a good question? Not saying your question's up. You could go out into the hallway and cough and kiss your boyfriend. Whatever. Go ahead, Christian.
Oh, I've yawned so much.
You caught that.
Nobody did anybody else catch that? That was hilarious.
I heard.
That was awesome.
Did you say my name? Yeah, I heard it. Trash.
Okay. Brandy, right here. What value am I going to pick for this one? Give me a value. 2 would work. I'm okay with 2 because 2 is greater than or equal to 0, right? It works. 8 times 2. Oh, shoot. 4 times 2. 8. 8 plus 3 is 11. So I'm up here. Okay? Coming over to graded. What's another value? I don't want to go really at this much further because I think it's too high. Let's do 1. 4 times 1 plus 3, 7. You did hear me finally.
Yeah, I heard it.
That was funny.
I heard it the first time. I was like, ah.
Okay, now Corey says let's do 0 because 0 actually works, right? So am I going to be a closed or an open dot? Closed dot. So, remember, you okay? 4 times 0 is 0, 0 plus 3. But notice here at 3 I'm going to be a closed dot, and I know it's going to be a line going like this. So what this is, guys, a piecewise function that says, hey, I'm technically, doesn't this graph technically keep going? Yeah, but what am I doing? I'm taking a portion of it. So like here's my graph, but I only want things that are greater than 0, so I'm only using this side. Does that make sense? Everybody with me on that? Hopefully, it's a very simple idea. Am I going to ask you domain and range? No. The domain's really simple, it's negative infinity to infinity, but the range can be like a little bit different. Because see how they have a little gap in between that? Okay, let's do another one.
Can we do ones off the homework?
Well, it does, but it doesn't. I'm gonna explain. Because you want to pick values that are working for that region of the piecewise, right? So like somebody was saying I want to use -5 or -6. Yeah, I could have. Why am I not? Because I already understand that that value kept getting me up. I need to get closer and closer to where I stop. I'll show you what I actually do. Okay, this is actually how I'm going to do it. I'm going to share the way I pick and I'm going to explain why I pick certain points, okay? Is everybody with me on this one? Okay, so I'm going to do a piecewise, x squared and square root of x. Just parent functions, right? First off, let's say I want this less than -2 and I want this, actually, let's do regular 2, positive 2. And I want this to be greater or equal to 2. Okay? Don't be laughing at me. I don't know. It's sort of mad. Shut your mouth, Mr. Black dressed man today. first off, I want to talk about this. What does the x squared look like? Boom. Am I using this whole graph? Because I'm using a portion, because notice the domain of an x squared is negative to infinity. That's what gives you this graph. But I'm only using from basically here and less. So it might start with a U shape and give you this part. So you need to understand what the shape should basically understand and look like. Does that make sense? If you see an absolute value, it should almost have a V. But notice, if they cut me off, is it a V shape if I cut me off here? I'm only using a line, am I not? You get what I'm trying to say by that? Okay, a square root looks like this. But if I cut me off here, I still have that arch, right? So I don't want it as a line. You need to still arch it a little bit. You get what I'm trying to say by that? Okay, here we go. Dylan, you ready? Numbers less than 2. What I always do is I start with the number that's on the inequality. 2. Is this going to be open or closed when I put it on the graph? It's going to be an open because it is less than. Not just because we can even flip-flop and make him equal to and not him. It doesn't always have to be the equal to on the bottom half. I'm just saying where it has the equal to is where it's going to be closed. Where it doesn't, it's going to be open. Is everybody with me on that? Okay. If you're not, think about it. Here we go. I'm going to pick 2. Is 2 less than 2? No. But I'm still going to use him to plug in here. 2 squared. 4.
Why the
I'm gonna just bear with me right here. Because here's 4. 2, 4. Now, I have an open circle, and the reason being is, what's the smallest, the largest value largest value smaller than 2? No. The largest value smaller than 2. 1.9999999, right? Is there actually a place on my graph to write that number? So I have to use 2 and say I'm coming up to it. Does that answer your question why I pick it? Okay? What's another good number? I'm not picking 4 because that's over here. I want to use the top half. I'm going to pick maybe 1 and I plug it in, I get 1. I get 0, I get 0. Negative 1, I get 1. 2, I get 4. 3, I get 9. Negative 3, excuse me. So it has the parabola shape. Right? I don't want half of it. I want to stop it at when x is 2. Now that's why I don't continue on this side, because I'm stopping it when x equals 2. Everything over here is when x was larger than 2. Okay, did I answer your question? Negative 2 squared is 4, isn't it?
Oh, yeah.
I'm just plugging it into my function. Okay. So, now here, I'm going to start with 2. What's the square root of 2? This one probably wasn't the greatest one to pick here, but the square root of 2 is not perfect, but we can find it out. Can somebody bring the square root of 2 and find out that estimate, please? I think it's 707 or something like that. Or point, I don't know. Oh, I was way off. 1.401? Okay, 41. Okay, so 1.41, so roughly about 1.5. Right here. Now this one's a closed dot because it isn't equal to. What's that? I'm just bear with me. I'm trying to do a half. I'm trying my best. That's why I said it wasn't probably the best number. What's the next nice number to pick? Should I pick 3? Probably not. How about 4? 4 would be a nice one because the square root of 4 is nice and it would just be 2. What's the next one nice to pick? 9. When I pick 9, it gets 3, and then notice, guys, I pick my arch of a square root graph. That's all it is. I pick the 2 points, I plot them, make sure the graph looks like what it should look like. Oh! I gotta quit throwing markers. That was totally it. Did it hit you in the chest or your face? Oh. Well, I gotta give it back to her. You can hear, I'm just gonna stand. Whoa! Okay, I'm covering this.
You can just have
No! It's not, I didn't hurt him. You get 1 shot.
him down low.
You never said you had to stay right there.
Get him down low, man.
Go, Maggie, so we can get on with the lesson. Hey, we're even. Sorry, Maggie. I apologize for getting you. Okay, so that's what the graph looks like because of the fact there's a square root, there's the parabola. Now understand, once again, this parabola keeps going. It does, doesn't it? But I don't want the stuff past 2. Not to the y value, but to the x value, right? That's why I stop it there. This graph technically actually goes over to 0 right here. It keeps going. But I don't want that extra part that keeps going over here, do I? Because I want from 2 on. Do you get what I'm saying? Okay. We're going to get the putting this back. No!
Sorry for the interruption. May I get Reagan Rossley to the attendance office for checkout?
Sure.
Thanks.
Love you. Pass that back to that lovely lady. No, you may not. Okay, basically let's do 2 more and we're going to call it quits. Okay? Here we go. This, I tell you, this is where I get some, cold sores because of all the stress you guys cause. Huh? You don't even know what cold sores are?
I've never had it.
I get cold sores when I get either A, sunburn, or B, I'm stressed. What? I don't take a darn thing. We'll get to it. It's something new. Bear with me. You sorry again. Say again.
Mr. Robert.
That is so sweet.
Oh, no.
I know it's horrible right now, but bear with me. It's Nick. Seriously?
Less than. Oh, no. I heard that. Nick, I swear. Hey, did you put your bag?
Yeah. Less than or equal to. No. See your target.
Put the dot on his head, but they could be the target.
Heat him. Oh, you're gonna
Sometimes I'm just very contentious here. Let's be realistic in our choices. Okay, here we go. So we start picking a value. Melanie, which value is it? We're gonna start. I always like to start with the top ones and go down. So Melanie, give me a value that you want to pick. 0 is a great one because 0 is less than or equal to 1. So I'm gonna say, okay, 3 to the 0 is. Thank you, Nicholas. When I got 0, I got 1. Okay. Dayton, give me another value that works in here. You just pick 0. Give me another one. Awesome. 3 to the negative 1 is 1/3, if you'll recall. Numbers up the line, change the sign. So negative 1 is at 1/3. If I did negative 2, that's at 1/9. Can I ever get past 0? Below 0? No, I can't go below 0 with a exponent key there. Okay. So, Carrie, give me another one. What? Whoa, where did you get that? Okay. Once again, I always like to start with the value that's on the inequality. I do. So I pick 1. 3 to the first would be 3. 3 would be. Okay? So therefore, if you recall, I'm just not going past here. Should this be an open or a closed dot? Closed because of the equal to, right? Remember the equal to's and stuff?
I-
You guys do not need that?
Oh, equal, yeah, but no, it depends.
I'm just graphing it. And notice it will never get below zero, so it approaches, because remember this is an exponential, right? We have an exponential growth and a decay, and this is a growth. Okay, now, Cassidy said, Mr. Roberts, are you missing something here? Is it just a -2, basically? That's almost what your question was, right? Let me ask a point. Give me somebody a point right here. Let's go. Swimmers. Give me a point right here. 2 is a great point, Swimmers. Great point. Okay? So when I plug 2 in, guess what I get? Negative.
No, wait. Why is like 2 minus 2?
Because I plug 2 in, but I have nothing x. It's always just going to be -2 no matter what. So, Sage, give me another value that works in here. 1, now is it going to be open or closed when I do this? Open, so when I do it, I get -2. But it's open.
Oh, at 1? I get that?
But it's open, because it's not technically available, right?
Oh, okay. I thought.
Starkey! Give me the last value I'm going to use. Oh, 3. Open or closed? Open. And notice, it's a straight line. Whenever you just see a value without an exponent or a variable around it, it's just a straight line. Because no matter what your x is, your y is always going to be that value. Make sense? Okay. We're getting there, guys. We're almost done. How you guys feeling? Is this a hard thing?
I want the homework.
It's a tedious thing, like I said, right?
Correct.
Okay. Yes.
What are the two values for?
This is at 1, -2. This is at 3, negative. This one right here? Exactly. So it's an in-between, right? The x is in between 1 and 3. Okay? That's basically what that's saying. Okay, and then the bottom one. Gooby, give me a value. I like 3 because I like to start where the inequality is. It's going to be closed or open. Closed, so notice that's a 9. 9 minus 1 is the 8. Good. So we're right here. Open or closed, we said closed. What's the next good value to pick? Not you. Just tell it to his face. You're very aggressive. Anyway, 2 would not be a good one. Is 2 greater than 3? 4 would be good, because, well, we want things greater, right? So 4, and notice we get 15. Now, I gave you 2 points. Most of you guys, I'll be honest, would do what? Probably would draw a line. What is that a line? What kind of graph is that? X squared minus 1. What kind of graph is that? X is, it's a parabola. It's the U shape, but I'm cutting it off right here. I'm just using this portion. So what do I need to make it look like? Kind of a U-er shape. It's not straight, it's kind of curved a little bit, right? This is a parabola.
Okay, it's just because you don't know.
Do you see what I'm saying? So therefore I want to make this, even though there's 2 points, just make it more parabola-ish. You know what I'm saying? Shut up. I didn't hear what you said. Hey, guys, that's a piecewise function. Really. Basically, you look at the values, understand, the thing you got to do is, what does this basically look like, though? So, yeah, it's an exponential, but I got to have an exponential until I stop it. So make sure it looks like the parent function of the graph until you stop it or whatever you need to do. Does that answer your question? Is that a pretty easy day? Does everybody feel comfortable picking a number and plugging in? Some of you guys are hesitant to pick the numbers that are on the inequalities. Don't. That's where I personally start, is the numbers on the inequalities. Then I ask myself, is it open or closed? I do switch the open and closed. Like this one is closed because there's the equal to. This one is open because it's just a greater than. This is an open just because it's a less than. This is a closed because it is a greater than equal to. Answer your question? Okay. Ready, set, break. No?